Welcome to Natural Polytechnic. I am Sima Raut, part of General Science Department. Subject Engineering Mathematics 1, Chapter number 1. Topic is Matrices and Determinants. Let's see what are the contents in this chapter. Contents are definition of matrix, types of matrices, transpose of a matrix, algebra of matrices, meaning of determinant, minor and cofactor of a square matrix, properties of determinant, inverse of a square matrix, and last, solution of simultaneous equations by Cramer's rule and also matrix inverse method. Let's see. What do you mean matrix? Set of mn numbers of elements arranged in the form of a rectangular array of m rows and n columns is called m by n matrix enclosed by open bracket or closed bracket. Let's see what are the elements in this matrix. All the elements must be real number or complex number or any functions. But with this chapter we just talk about elements must be real number. Okay, so m for number of rows, n for number of columns, and those m and n are from natural numbers. Okay, let's see. So let's see, that is a matrix. Matrix naming as any capital letters, just like as A, B, C, capital letter A, B, C, D, any capital letter. So here A, capital letter A equals the matrix name is here. There are mn numbers of elements, m number of rows and n number of columns. Rows means number of horizontal lines. Columns means number of vertical lines. So m number of horizontal lines, n number of vertical lines is there. So every element is symbolized by A11, A12, A13, A1n, A21, A22, A23, A2n, AM1, AM2, AM3, AMn. That means A22 means the element of the position second row, second column. A23 means the element of the position second row and third column. AMn means the element of the position mth row and nth column. Okay. So that means in this way the arrangement of the elements are shown in this figure. Okay. For example, A is a matrix where the matrix elements, there are 6 number of matrices, and how many rows is there? 1, 2, 3. And how many columns is there? 1, 2. So order should be the matrix of order 3 by 2. B is a matrix, there are how many rows? 1, 2. How many columns? 1, 2. So how many total elements is there? 2 into 2 equals to 4 elements is there. But we say that matrix of order 2 by 2. Okay, let's see. Types of matrices. What do you mean types of matrices? There are several types of matrices, but we talk about some types of matrices in this chapter. Row matrix. Row matrix means only one row is there. Number of columns may be more than one, but number of row must be one. So A equals to -1, 2, 0, and B equals 0, 11, -2, 4. So here A is a one row only. How many columns is there? 1, 2, 3. So order should be 1 by 3. Here B matrix 1 row and how many columns? 1, 2, 3, 4. So 1 by 4. Let's see. Column matrix. A matrix of order m by 1 means one column only. Row may be more than 1. So here for example A is a matrix where -1, 2, that means one column is there. How many rows is there? 1, 2. 2 rows is there. So order should be 2 by 1. So A matrix here is a column matrix. C is a matrix where number of rows are 5, number of columns are 1. So order of this matrix is 5 by 1. So C also a column matrix because only one column is there. Zero or null matrix. That means the matrix may be any order, but the every element, each and every element of this matrix must be 0 with any order. So this type of matrix is called as zero or null matrix. Symbolized as only 1 0 and matrix symbol. Okay, let's see. Rectangular matrix. A matrix in which number of rows is not equals to number of columns, then we call as rectangular matrix. Means number of rows is symbolized as m, number of columns is symbolized as n. So m is not equals to n, then we said that rectangular matrix. Let's see for example, here is a matrix, there are how many rows? 1, 2, 3, 4. How many columns? 1, 2. So here 4 is not equals to 2 obviously. So m is not equals to n. So this type of matrix is called as rectangular matrix. Square matrix. A matrix in which number of rows equals to number of columns. That means m equals to n. So this type of matrix, let's see, for example, A is a matrix where number of rows are 3, number of columns are 3. That means here number of rows m equals to 3, n equals to 3. That means these are two are equal. So we said that this matrix is called as square matrix. And one thing is that if this type of matrix, square matrix, symbolizes as matrix of order 3 only, because here m equals to 3, n equals to 3. So we can call as matrix of order 3 only. If m equals to 2 and n equals to 2, a 2 by 2 matrix, then we can say that matrix of order 2. That means we said that this matrix is a square matrix of order 3 by 3. This matrix is a square matrix of order 2 by 2. Okay, let's see. Diagonal matrix. A square matrix in which if all the elements except leading or principal or main diagonal are zeros. That means, what do you mean mid leading? We know that that should be a square matrix. Okay, 3 by 3, 2 by 2, 4 by 4, this type of matrix. And here, the leading or main diagonal. What do you mean principal or main diagonal? There are two diagonals. One is right corner diagonal, another is left corner diagonal. But always right corner diagonal in a matrix is called as principal or main diagonal. Why? Because in a right corner diagonal, every element is the position I equals to j position. That means here this is the position of 1 1, means first row, first column. This is the right corner diagonals elements. This -3 position is 2 2, means second row, second column. And third element also 3 3 position. That means I equals to j here. 3 3 means same position, 3 3. That means the number of row number is 3, column number is 3. So 3 3 position is 2. So always the principal diagonal position must be I equals to j. So right corner diagonal is called as leading or principal diagonal, not left corner diagonal. So always remember that matrix right corner, square matrix right corner diagonal is called as principal or main or leading diagonal. So let's see. Except leading diagonal, every elements of the square matrix is 0, then this is called as diagonal matrix. Okay, let's see. What do you mean scalar matrix? Scalar matrix starting from a diagonal matrix. A diagonal matrix with all diagonal elements are equal. That means every 2 2 2 3 3 3 minus 2 minus 2 minus 2, every diagonal, every elements of the diagonal, main diagonal must be same. Then this is called as scalar matrix. That means every diagonal matrix is not scalar matrix, but every scalar matrix is a diagonal matrix. Okay, let's see. Unit or identity matrix. A diagonal matrix whose elements in main diagonal are 1, then this is called as unit matrix. That means in scalar position, every element must be 1. In right corner, diagonal matrix right corner, diagonal matrix main diagonal, elements must be 1 1 1. So that means this is a diagonal identity matrix of order 3. I3 means identity matrix of order 3. That means every identity matrix is called as scalar matrix and every identity matrix is called as diagonal matrix. But every diagonal matrix is not identity matrix or every scalar matrix is not identity matrix. Okay. Let's see. Equal matrices. Two matrices are equal if they have same order and same corresponding entries of elements. That means order must be same, matrix order must be same, and elements must be corresponding to elements must be same. That means here A order is 3 by 2, B order also 3 by 2. Or now if 1 equals to x and D equals to 1 and A equals to 3 and 0 equals to y and C equals to 1 and B equals to -2, then these two matrices is called as equal matrices. Last one is singular and non-singular matrix. That means the square matrix B, let it be, is a singular if the determinant of this matrix is 0, otherwise non-singular means not equals to 0. That means we don't know about now the determinant, but next video we talk about determinant. But just remember that singular matrix means determinant, square matrix determinant must be 0, non-singular means otherwise means not equals to 0. For example, B is a matrix, this is a square matrix of order 2. Number of rows are 2, number of columns are 2. Determinant is not equals to 0. 5 means not equals to 0. That means this B matrix is a non-singular matrix. Next class we talk about transpose of a matrix. Have a good day. Thank you.